So the first test paper beta 1 to 45 questions. First question is from your magnetic effects of current. An electron traveling with a velocity of 60 I cap meter per second to a point in space where magnetic field is 0.1 J cap. The force on the electron at this point is F is equals to 9.6 into 10 power minus 19 I cap minus 9.6 into 10 power minus of 19 K cap Newton. The electric field will be equal to your how much? Anyone? Charge is given and magnetic field is been given better. How do you calculate the force? Force acting on the electric field will be equal to how much? F is equals to Q into V bar cross V bar. Okay. The electric field has been calculated by the formula F is equals to E into Q. Okay. When we are having both electric field and magnetic field, we'll be applying what force beta? Lorentz force. That means E is equals to F divided by Q. Done? Here. Now it is in both electric field and magnetic field simultaneously. So we can apply your Lorentz force. Apply both of them at a time. What is the Lorentz force formula beta? F is equals to force due to magnetic field plus force due to electric field. Okay. Force due to magnetic field is what? Q into V bar cross B bar. Plus this due to electric field will be equal to how much beta? F is equals to E into Q. And this is your F. Done? Calculate the electric field from that one. Everything is given for me in the problem. Electric field will be equal to how much for me? EQ will be equal to force is given for me right now in the problem. It is your Q into V bar cross B bar minus of your F. Yeah. So electric field means this will be equal to how much for me? V bar cross B bar minus F will be equal to how much? But F divided by charge. Because Q and Q here will get cancelled, K will get cancelled. This is the electric field formula. Okay. So you can write ultimately, I don't have the space. So I'm rubbing this one here right now. If I rub this given condition, I can write the direct formula for this one as electric field E is equals to F divided by Q minus V bar cross B bar. So force is given for me how much? 9.6 into 10 power minus 19. Both of the magnitudes are same. It will be your I cap minus of your K cap divided by charge of electron. Charge of electron minus 1.6 into 10 to the power of minus 19 minus V bar cross V bar. V bar is right now 60 I cap cross magnetic field is 0.1 J cap. Okay. So 10 power minus 19, 10 power minus 19 will get cancelled here right now. So this will be equal to your 1.6, 9.6 divided by 1.6. And that's your minus of your 6 into I cap minus of your K cap. Minus 0.1 is nothing but 1 by 10. This 0 will get cancelled. So this will be equal to 6 into I cap cross your J cap. You know what is I cap cross J cap beta? K cap. So this will be equal to here. I'm writing here. This is minus of 6 I cap. This will be plus 6 J cap minus 6 into your K cap. I cap cross J cap is nothing but equal to your K cap. Okay. So this positive and this negative will get cancelled. Ultimately, the answer will be minus of 6 I cap Newton per volt. Got it?
Yes.
Sure. So what is the formula when electric field and magnetic field has been given? Electric field is equals to your EQ minus of your V bar cross B bar. How I got that one? From the formulation of your F magnetic plus F electric. Magnetic means Q into V bar cross B bar. Electric field means E into Q. That will be equal to your F. Okay. Now if I need to calculate the electric field, E into Q is equals to your F minus of your Q into V bar cross of your P bar. So Q is equal, electric field E will be equal to how much better? F divided by Q minus of Q divided by Q into V bar cross B bar. So this Q will get cancelled. So answer is F into Q minus of your V bar cross B bar. That is the way how I got that formula there. Sure. Next one is unit vectors. If you can able to do, try to do it out. But let us try to go for the next one. Next one is current kinematics and question number 4. Beta. Good question. Anyone? If a variable frequency AC source is connected to a capacitor, that means we are having a capacitor. Into this capacitor, we are connecting an AC source with decreasing frequency. Frequency is decreasing. So what happened to the displacement current? You know that displacement current is nothing but equal to conduction current. When it is connected to the capacitor, Xc is equals to 1 by C omega. That is equals to 1 by C. Omega is equals to 2 pi into your F. Clear? So frequency will be equal to how much for me? 1 by 2 pi C into your Xc. Clear? So capacitor and frequency relation is right now for me what? Inversely proportional. So with the decrease in frequency, the displacement current, what happens? When you are decreasing the frequency beta, Xc will be your increasing. So when Xc is increasing, current flow will be capacitor decrease because resistance is increasing now. If frequency is right now for me decreasing, Xc will be your increasing. Xc is nothing but what? Capacitive reactance. There's something like a resistance. So if it is increasing right now for me, what is happening? Current flow throughout the capacitor will decrease. So in case of capacitor, displacement current is nothing but conduction current. So with the decrease of frequency, displacement current will also decrease. So what is the best option I can write? C. Clear? Got it?
Yes, sir.
Decrease in frequency, Xc will increase. If Xc is increasing, it will not allow the flow of current. If it is not allowing the flow of current, means current is decreasing. So displacement current will be decreasing. Sure. Next one. The focal length of a convex lens of refractive index 1.5 is 20 centimeter. The focal length of a lens when it is immersed in the liquid. This is also a good question, better. So whenever you are immersing it in your liquid, first tell me what is the focal length of the formula? 1 by F is equals to lens maker's formula. Mu minus 1 into 1 by R1 minus 1 by R2. Okay, so that is your lens maker's formula. 1 by F is equals to mu minus 1 into 1 by R1 minus 1 by R2. Sign convention, R1 will be equal to positive for convex lens, R2 will be equal to negative. Clear? Now, sir, when it is in air, right there, 1 by focal length in air is equals to refractive index of glass with respect to your air. Glass with respect to your air particle relation. That is glass with respect to air minus 1 into 1 by R1 minus 1 by R2. When it occurs in the liquid, 1 by focal length in the liquid is equals to refractive index of your glass with respect to the liquid minus 1 into your 1 by R1 minus 1 by R2. If I take the ratio of this one, that is 1 divided by 2. Focal length of your liquid divided by focal length of air. These two ratios will get cancelled. This will be refractive index of. So whenever you are writing refractive index of glass with respect to liquid means refractive index of liquid divided by refractive index of glass. Refractive index of glass with respect to air means refractive index of your glass divided by refractive index of your air. So it is 1 by focal length of the lens divided by focal length in air will be equal to refractive index of glass divided by refractive index of liquid minus 1 divided by, for air it will be equal to how much better? Refractive index of your glass divided by refractive index of air minus 1. Okay. refractive index of the convex lens of is how much for me? 1.5, and focal length of the lens when it is immersed in the liquid of refractive index 1.2 will be equal to how much? So focal length of air is given for me. How much it is right now for me? 20 centimeter. We need the focal length in the liquid. So it is 20. Refractive index of glass is, already refractive index of glass by default will be equal to how much for me? 3 by 2. So it is 1.5 divided by 1.25 minus 1 divided by glass is 1.5. Air is nothing but 1 minus of your 1. See how much I'm getting this one? 1.5 means 3 by 2. 3 by 2 minus 1 is right now how much for me? But 1 by 2. 1.5, 1.1 minus 2, 1.25, 1 by 4. That means it will be equal to 1 by 5. So this will be equal to 2 by 5. So focal length of the liquid will be equal to 2 by 5 times of the focal length of your air. So that is equals to 2 by 5. Focal length of air is nothing but 20. 5 ones are 5 fours are 4 twos are 8. This will be equal to your 8 centimeter will be the answer. Done? So this is the formula which you need to remember. Whenever a convex lens is immersed in a liquid, focal length of the liquid divided by focal length of air is equals to refractive index of glass divided by refractive index of liquid minus 1 divided by refractive index of glass divided by refractive index of air minus of your 1 part deflation. Clear? Is that formula clear? What is the actual formula for the lens makers beta? 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. For convex lens, r1 is positive, r2 is negative. What do you mean by convex lens beta? Convex lens appears to be like this. This is your convex lens. So r1 is positive, r2 is negative. Whenever it is immersed in the air, this is the formula. When it is immersed in the liquid, this is the formula. If I take the ratio, we are getting this formula. Clear? Sure. Question number 6. This is also a good question. Anyone? Infrared wave is observed by an ozone layer of the atmosphere. Very good question. During the propagation of electromagnetic waves in a medium, energy density is equal to the magnetic energy density. In the light of above statement, choose the most appropriate answer from the options given below. Can anyone tell me what will be the answer for this one? Statement 2, is it correct or false, beta? I already told you in electromagnetic waves, during the propagation of an electromagnetic wave in a medium, during this propagation of electromagnetic wave in a medium, the electric energy density is always equals to magnetic energy density. This statement is true. So second statement is correct. Second statement is correct is coming in the A and as well as of your D. First statement beta, infrared rays. Infrared rays is not observed by the ozone layer beta. It is observed by small dust particles and water vapors. Okay, so infrared rays are not observed by the ozone layer. Make sure of that one, because it is only observed by the small dust particles and as well as of your water vapors. So the best option for this one will be equal to your. What is the best option I can write? D will be the answer. Statement 1 is incorrect and statement 2 is your correct one. Clear? Question number 7. Anyone? Which of the following units denotes the dimensions of ml square divided by q square? Dimension formula concept. L is nothing but what beta? Which of the following units? Q represents the electric charge. Denotes which of the following units denotes the dimensions ml square divided by q square. Q is charge. Weber per meter square, Henry per meter cube, Henry Weber. Weber is unit of magnetic flux. Henry. What is Henry unit beta? L. Inductance unit. Like energy U is equals to, if I write this formula, U is equals to half into L into I square. L is equals to how much for me? 2 into U divided by I square. That is 2. Energy of dimension is ml square t power minus 2 divided by current is I is equals to Q by T. Q is measured right now for me Q divided by time is nothing but T. So it is q square divided by your t square, isn't it? So this value will become how much for me? 2 anyhow is constant. It is your ml square divided by q square. Ml square divided by q square is a dimension of what beta? L. L is nothing but unit of N. L is nothing but what? Henry. That is nothing but H. So C will be the answer. Clear? Question number 8. What should be the value of the distance d so that the final image is formed on the object itself? You know that whenever object and image are coinciding, that means it should have been kept at the center of curvature. Since object is placed at the focus of convex lens beta, so after refracting through the convex lens, all the rays will go parallel. Again, this ray will pass through the concave lens, and the concave lens will diverge these rays, and virtual image will be formed at the focus of 20 centimeter. That means the total distance will be equal to how much for me? Already distance is right now for me this 10 object distance. This is your 10 plus of your d, and image will be formed at your center of curvature right now for me when it is been coinciding. That means it should be equal to 20. So d will be equal to your 10 centimeters. Okay, because if the object has been incident on this one, if I draw the ray diagram, it will incident on this one, it will try to converge here and will try to diverge here, right? If I insert this one backward, again it has been forming at the same side, isn't it? That means focal length of this one is of your 20 centimeters. So this 10 plus it go to must be equal to how much per meter? Radius of curvature. So what should be the value of the distance d so that the final image is being formed on the object itself? So when the final image is forming on the object itself, means the object should have been kept at the center of curvature. So 10 plus d must be equal to your 20 focal length. So this will be the answer. Clear? Sure. Question number 9. Even what will be the escape velocity v of your rocket of mass m if it is situated at the midpoint of a line joining the two planets, each of mass capital M at a distance of your r? So many times I told you, how do you apply this one? With law of conservation of mechanical energy. What will be the escape velocity of your rocket? I'll do here right now. Okay. What will be the escape velocity v of a rocket of mass m if it is situated at the midpoint of line joining the two planets? That means we have got a two planets here. This is one planet, and this one is your another planet. And this is the center of this part, and this is center of this part. Mass of this one is capital M, and mass of this one is capital M. This is somewhere here we are keeping a particle of mass m, and we are giving it certain velocity for the projection with a velocity v, and it is going up to the infinity. So this distance is r by 2, this distance is at your r by 2. Okay, so total energy of the rocket will be equal to how much beta initially? So total energy will be equal to half into m into v square minus, it will be equal to how much for me? Potential energy because of the two objects. So it will be equal to your 2 into capital G, capital M, small m divided by distance between them is your r by 2. And final energy is anyhow 0 right now for me. So final energy will be equal to your 0. So from law of conservation of energy, total initial energy on the surface of the earth must be equal to total final energy, isn't it? So final energy is 0. So it is half into m into v square must be equal to your 4 into capital G, 4 into your capital G, capital M, small m divided by your r. Clear? Done, beta. Why I got for this 2? This 2 is going up. And this small m and this small m will get cancelled. V square will be equal to 4 to the 8. 8 times of capital G, capital M divided by your, this will be equal to your R. So V value will be equal to how much for me? V is equals to, it is under root of your 8 capital G, capital M divided by R. Root 8 can be written as of your 2 root 2. 2 root 2, this is under root of gm divided by your 2. That means I can write this one as 2 under root of your root 2 is nothing but to take the inside, it will become for me 2. 2gm divided by r. You can directly write like this. Done. So which option is matching? 2 times of under root of 2gm divided by r. First option will be the answer. Okay, sure. Question number 13 to understand. Anyone? In the given cycle A, B, C, D, E, the heat required for an ideal monatomic gas will be equal to how much? AR. I'm waiting for that one. 10 and 11, you must give me the answers, but faster.
Sir, screen is struck.
Yeah. Question number 10 and 11, you tried. In a given cycle A, B, C, D, A, the heat required for the ideal monatomic gas. A to B, pressure is constant, isobaric. B to C, volume is constant, volume. So isochoric process. C to D, isobaric. D to A again, isochoric. That means work done from B to C and D to A will become zero. Is asking us heat required for an ideal monatomic gas. Tell me in which cycle heat is supplied. When we are going from D to A, volume is constant, pressure is increasing. So work done will be V naught into change in pressure is there. P into delta V.
Sir, your screen is paused, sir.
Screen is paused. Now,
No, fine, sir.
okay, check. Question number 10 and 11 better. In a given cycle A, B, C, D, A, heat required for an ideal monatomic gas will be equal to how much? Understand the terminology of a question. Very good question, better. In the given cycle A, B, C, D, A, heat required the gasoline. What do you mean by heat required? Heat required. See, in the process from D to A, in the process of your D to A and A to B, in D to A, pressure is P naught to 2P naught. Where heat is supplied. And A to B at a constant pressure, in this one is also it is supplied. Okay. Now from D to A, volume is constant better. So heat supplied formula will be equal to how much for me? Monoatomic gas. So Q will be equal to your how much for me? Yeah. Q is equals to N into CV into delta T from your process of D to A plus N into pressure is remaining constant, temperature difference into your A to B. In these two processes, heat is supplied or heat required, you can say. As it is a monoatomic gas. For an ideal monoatomic gas, what is the value of CV beta? For monoatomic gas, constant CV will be equal to 3 by 2 times of R. Cp will be equal to 5 by 2 times of your R. Okay. And I can write nRT in terms of what beta? So Q is equals to N into 3 by 2 into R into delta T. Plus this is right now for me N into Cp will be equal to 5 by 2 into R into delta T. So I can write this one as of your 3 by 2 and R into delta T can be taken as of your pressure into your change in volume. 2P naught minus P naught. It will be equal to how much or me better? P naught. Isn't it? Plus 5 by 2 into nRT. So this will be equal to 5 by 2, and nRT is nothing but pressure into change in volume. From A to B, pressure will be equal to how much beta? 2P naught. Volume will be equal to your 2V naught, isn't it? So 2V naught, pressure will be equal to how much for me? 2P naught. Volume will be 2V naught minus V naught. It will be V naught. Again, this two will get cancelled. Clear? So this value will be equal to 3 by 2 times of P naught V naught plus it is your 5 times of your P naught V naught. Simplified will get the answer. Got it? D to A work done is equals to, because P into delta V is equals to NR into delta T beta. Now for C, D to A process, pressure will be equal to 2P naught minus P naught into volume will be equal to how much better? V naught. So P2 naught minus P naught is nothing but P naught into V naught. That is the reason in the place of N into R into delta T, I got it as P naught into V naught. Then from A to B, for your A to B process, pressure will be equal to how much for me? 2P naught into volume will be 2V naught minus V naught. So it is 2P naught into V naught. That is the reason I got here 2P naught into V naught. 2 and 2 will get cancelled. 3 by 2 P naught V naught plus of your 5 times of your P naught V naught. So how much I'm getting this one? 3 by 2 plus of your 5 into P naught into V naught. How much? 5 is 15, 15 minus 2. This will be equal to 13. 13 divided by 2 into P naught into V naught. That will be the answer. B. Done? So next one. 11th one, and very important question. So semiconductors and devices. In the circuit shown below, the diode has a 20 ohms forward bias resistance. When Vi increases from 8 volt to 2 volt, the change in the current will be equal to how much? Can anyone? In the circuit shown below, the diode has a 20 ohm resistance. So this is a forward bias. So it is a 20 ohm in forward bias. When input potential increases from 8 volt to 2 volt. Okay. Tell me what will be the total resistance beta? 200 plus 20. These two are in series. So resistance of the circuit will be 200 plus 20. This will be 220 ohms. Okay. Vi increases from 8 volt to 10 volt, 8 volt to 12 volt. Then beta. Here forward bias potential is given how much better? 10 volt minus P junction. This is P and this is N. Now see here, diode will be in the forward bias when Vi is greater than, input potential must be greater than this 10 volt beta. For 8 volt, it will be reverse bias. It will not work, isn't it? So it will work only if it is greater than 10, like 10, 11, 12, it will work. So Vi, if it is lesser than 10 volt, the diode will not conduct because it will be in reverse bias. So initial current will be equal to how much beta? For 8 volt, initial current will be equal to 0. Now when Vi is 12 volt, the diode will be in forward bias. So potential will be equal to how much beta? 12 minus of your 10. Here input potential is 12 volt, here it is 12. So change in potential will be 12 minus 10. That will be equal to 2 volt. Now what will be the current at the time? I2 will be equal to, I in 1 is equal to 0. I2 will be equal to your change in potential divided by resistance. There is 2 divided by 220. So that will be equal to 2100. 100 double point 009 ampere. That is approximately 9 milliamperes. Now is asking the change in current. Delta I will be equal to how much for you? I2 minus of your I1. I1 is 9 milliamperes. Initial value is nothing but 0. So the answer will be equal to how much for me? 9 milliamperes. Got it? See here, N is 10 volt beta. So your input potential must be greater than 10. Then only it will be forward bias. Like say now for 8 volt, it will be reverse bias. There is no current. So I1 will be equal to 0. Then when V input potential is 12 volt, then it will start conducting. So 12 minus 10, it will be 2 volt. When you know resistance is nothing but 200 plus 10. So it is 210. So I'm calculating I2. I2 is delta V divided by R. 2 divided by 220. It will come for me 0.9 milliamperes. So it's asking the change in current. I2 minus I1. 9 minus 0 is 9. So it will be 9 milliamperes. Then which in the 11th one important model beta. అర్థమైందా మనోజ్ చెప్పనా? Shall I tell you once again? Hmm? Afia got it? Shall I tell you once again?
Yes, sir.
Shall I tell once again?
Yes, sir.
Not understood. Okay, I'm doing once again. Yes. See the question. In the circuit shown below, the diode has 20 ohm resistance. That means the resistance of this one is 20 ohms. And it is in forward biased. When input potential increases from 8 volt to 12 volt. So initially is how much for me? 8 volt. Then after certain interval at time, it is 12 volt. Now, but here this is P and this is N. N is already given in the problem. The potential is 10 volt. This diode will be your forward bias if and only if your input potential is greater than 10. That means for the 12 volt, it will be forward biased. And for 8 volt, it will be reverse biased. So when it is 8 volt, when input potential is 8 volt, initial current will be equal to 0. The same way, when input potential is 12 volt, input is greater than your output. So at that time, the change in potential will be 12 minus 10. That means 2 volt. In that case, 220 are in the forward bias. So R effective will be equal to how much? 200 plus 20 series combination. It will be 220. So determine forward bias. What is the current? I2. I2 is equals to delta V divided by R. Delta V is 220 divided by resistance. Resistance, sorry. Delta V is how much? 2. Delta V is equals to 2 volts. So it is 2 divided by R will be equal to how much for me? 220. So it is 11100. So 1 by 100 will be equal to approximately, if I'm taking the value of this one, it is 0.009 amperes. That means it will come out for me 9 into 10 to the power of minus 3 amperes. It is 9 milliamperes. What is asking the change in current? Change in current is delta I. Delta I means I final minus I initial. I final is how much? 9 milliampere. I initial is how much? 0. So it is 9 milliamperes will be the answer for this. Got it?
Yes, sir.
Sure. You need to see the diagram very carefully better when two voltages are being given. Otherwise, there is a lot chances that you can do the mistake for such type of questions. Sure. Question number 12. Question number 12. If lambda 1, lambda 2, lambda 3 are the wavelengths of the waves giving resonance into the fundamental first and second overtone modes respectively in a string fixed at both the ends, the ratio of the wavelength will be equal to how much? Now it is fixed at both the ends, isn't it? And frequencies are given for me F1, F2 and F3. Fundamental node, first node and second overtone nodes. First one is fundamental, next one is first overtone, next one is second overtone mode. And when the string is fixed at both the ends, what is the ratio of the frequencies bit I told you? F1 is 2, F2 is 2, F3 will be equal to 1 is 2, 2 is 2, 3. Okay, so wavelength is inversely proportional to your frequency. Second right here, lambda 1 is 2, lambda 2 is 2, lambda 3 will be equal to 1 by F1 is to 1 by F2 is to 1 by F3. 1 by 1 is nothing but 1. The next one is 1 by 2. The next one is 1 by 3. So what will be the ratio? Lambda 1 is to lambda 2 is to lambda 3 will be equal to how much were we? How much I'm getting better?
Sir, option 1.
Option C, Elliot. Because it is ratio, no? 1 is to 1 by 2 is to 1 by 3. It will be 6 is to 3 is to 2. Isn't it? See, if I divide it by 6, 6 is a 1, then 3 by 6, then 2 by 6. 3 ones are 3 twos are, 2 ones are 2 threes are. So it is 1 is to 1 by 2 is to 1 by 3. So answer will be 6 is to 3 is to 2. Done?
Yes.
Sure. 13th one. The drift velocity of the free electrons in a conducting wire is in the order of 10 power minus 4 meter second. And the bulb glows very quickly after the switch has been turned on because the random speed of the electron is very high as the order of 10 power 6. The electron transfers their energy very quickly through the collision. Electric field is set up in the wire with a speed of light producing a current change. Current through each cross section is almost instantaneous. The random speed of the electron is very low order of 10 power of your minus of your 6. What will be the answer, better? The moment there is a drift velocity, electric field is been set up in the wire with a speed of light, producing a current through each cross section, which is almost all instantaneous. That is the reason the current will be glowing instantaneously. So C will be the best option for that. 14th one. A short bar magnet of magnetic moment 0.15 joule per Tesla is placed in a uniform magnetic field of zero point 0.4 Tesla. The potential energy of the magnet in the unstable equilibrium will be equal to how much? Magnetic energy formula U is equals to minus of your MB into your cos theta. Magnetic moment is given how much, better? 0.15 joule per Tesla into magnetic field is given as 0.4 Tesla into theta is how much, better? Unstable equilibrium it is telling. So it will be your 180 degrees. Okay, so cos 180 is how much for me? Minus 1. So it is minus of 0.15 into 0.4 into minus of your 1. So simplify it, we'll get the answer. Minus of minus it will be plus 30. 15 4 is 16. 6 means x into 10 power minus 2. That will be the answer. Okay, sure. Now this question you should tell me, but I'm not doing this one. Match the list 1 with the list 2. Chapala, units and dimensions question. Anyone you do it and match it better first. You can take frequency. Frequency is reciprocal of the time. So C is matching what? Steradian is
4,
an
sir. 4. Frequency is 4.
dimensionless quantity, na? So A will be
Yes, sir.
matching with your 3. A is matching with your 3. We are getting 3 options. Okay. Then frequency. Frequency is reciprocal of the time
4,
period.
sir.
So frequency is matching with your 4. That means C must be 4. C must be 4. So which option? B, isn't it? A is matching with your 3. C is matching with your 4. A is matching with 3. Here C is not matching with 1. So this is not possible. This is not possible. This is also not possible. Only third option, second option will be possible. Sure. Question number 16. For a cell VI graph is given. Everyone. V versus I graph will be giving me what, better? EMF of the cell. See, when potential is 0, current will be equal to 0 from the graph. Current is 0 when V is equals to 1.5 volt. Sure. Simplify that one. See what happens. When V is equals to 0, current will be equal to how much? Or I can say that I is equals to 0 at V is equals to 1.5 volt. So EMF of this cell will be equal to how much? 1.5 volt. The same way, at V is equals to 0, when V is equals to 0, current is how much for me, beta? I value is coming out for me 1000 milliamperes. That is nothing but equal to your 1 ampere. Isn't it? Now, when I know the EMF, when I know the current, can I calculate the for the given cell? Which of the following options give the correct value of EMF of this cell? And internal resistance. Internal resistance EMF, I already got 1.5. 1.5 is in the three options, so C is not possible. 1.5, 1.5, 1.5. There should be an A, B, and D must be the answer. Now, internal resistance means E minus V is equals to I into R beta. Isn't it? So EMF is right now 15. Initial potential is equal to how much for me? 0. Current is right now for me equal to how much for me? 1 into internal resistance is R. So R will be equal to how much for me? This is 1.5 now. 1.5 ohms. So which is the best option I can write? 17th one beta. Two coaxial solenoids are made by winding the thin insulating wires over a pipe of cross-sectional area. A is equal to 10 centimeters square, length is 20 centimeter. If one of the solenoid has 500 turns, another has 300 turns, then their mutual inductance is how much? This is directly formula-based conditions better when number of turns are being given. Mutual inductance will be equal to, I'm writing the formula, you do the calculation, mu naught into N1 into N2 into area divided by length L. So this is the formula when two number of turns are being given for. 18th one, I hope you can tell me. Consider the charges on the surface is shown in below. Electric flux through the surface is how much? Only charges which are enclosing, that will give me the flux beta. Phi q, q and 2q. What is the formula? Flux will be equal to how much for me? Flux is equals to charge enclosed divided by epsilon naught. Flux is equals to charge enclosed divided by epsilon. What is charge enclosed beta? It is 5 plus 1 minus of your 2 divided by epsilon. This will be equal to your 5q, 2q. That means this value will become for me 4q divided by epsilon. This is every times is right now q. This 4q divided by epsilon. And 19th one you should tell everyone. Nitrogen atom is given energy of 10.2 electron volt. How many spectral lines will be emitted due to the transition of an electron? I'm waiting for your answer. Directly formula based questions will. A nitrogen atom is given energy of 10.2. How many spectral lines will be emitted? What is the energy of nth orbit formula beta? Energy of nth orbit is equals to minus 13.6 divided by n square into electron volt. Okay. Now for ground state, what is the energy beta? For ground state, that means n value is equals to 1. Energy will be equal to minus 13.6 electron volt. That is initial energy. For first excited state, n is equals to 2. First
One.
excited state, n is equals to 2. Energy E2 will be equal to how much beta? Minus 3.4. So if I take the difference, where I get E2 minus of E1, so that will come out for me how much? 10.22 electron volt. So whenever electron is being in excited state, that is, it is undergoing only from where? N2 to 1. That means only 1 must be the answer for that. Very good.
Yes, sir.
20 we have not done. 21 is again direct question. Anyone? Graphical question. The stress versus strain graph is a straight line passing from the origin. The two materials are there, A and B, as shown in the figure. If YA and YB of the Young's modulus of material, then what is the relation between them? Tell me, slope of this one will always give me what beta? Young's modulus only, na? Write your formula. Slope of your A divided by slope of your B will give me the Young's modulus of B divided by Young's modulus of your A. Because stress is equals to Y into strain beta. So stress divided by strain is equals to Y. But given in the problem is strain divided by stress, ulta. That is the reason it is 1 by Y, but not Y. That is only the difference you need to remember. Okay. For slope of A is how much beta? 60. So it is your tan 60 divided by tan 30 must be equal to Young's modulus of B divided by Young's modulus of A. Tan 30 is root 3. This is 1 by root 3. That is equal to Young's modulus of B divided by Young's modulus of A. So that will be equal to how much for me? 3 is equals to YB divided by YA. That means YB is equals to 3 times of YA. Which option? Third one. See. The next one is your calorimeter. Then 23 is again gravitation. This one you should tell me. The escape velocity is 11.2 km per second. If a body is to be projected in a direction making an angle of 60 degrees to the vertical, then what is your escape velocity? Escape velocity is not depending upon angle of projection beta. Hence, the escape velocity will remain for me the same. There is no change. It will be how much for me? 11.2 kilometer per second. Clear? Next one. 25 try to understand. If an electron in n is equals to 4 orbit of an hydrogen atom jumps down to n is equals to 3 orbit, the amount of energy released and the wavelength of the radiation emitted will be equal to how much? Just now we used the formula. Energy E is equals to minus of 13.6 divided by n square electron volt. From electron is jumping from E4 to E3. That means directly I can write E4 minus of your E3. That will be equal to 13.6 into 1 by 3 square minus 1 by 4 square. So that will be equal to 13.6 into 3 square is 9, 16. So this value will be 16 minus 9. That will be equal to your LCM is 144. This one is here 13.6 into 9. 16 minus 9, it will be equal to 7. Okay. So how much you see? 13.6 into 7 divided by 144. I'm getting this one as 0.66 electron. Amount of energy released and the wavelength is asking. Energy I got 0.66. So I need not do the second option. Directly you can take it out. First option will be the answer. Sure. 26, I hope you can do better. At the time of the adiabatic process, the pressure of a gas is proportional to the cube of its absolute temperature. The value of Cp by Cv will be equal to how much? So many times we did this one. Relation between temperature and pressure. What is the relation, beta? Can you tell me? T power of your gamma, P power of your T power of your gamma, P power of your 1 minus gamma is equals to constant. Isn't it? If I'm writing the pressure and temperature relation, just transfer the powers. This will be P power 1 minus gamma proportional to T power minus gamma. So if I transfer the powers, P is proportional to T power of your gamma divided by gamma minus 1. This will be the relation. So now in the given problem, P is directly proportional to T power 3. So I can write here gamma divided by gamma minus 1 will be equal to how much for me? 3. That means this is gamma is equals to 3 times of gamma minus 1. So it is 3 gamma minus 3. So this will be equal to how much beta? Gamma is equals to 3 gamma. This will be 2 gamma. So 2 gamma is equals to 3. Gamma is equals to 3 by 4. Sure. Question number 27. If the frequency of incident photon in a metal surface is doubled, then stopping potential will become how much for me? Anyone? The frequency of incident photon in a metal surface is doubled. What happened to its stopping potential? Use the Einstein's photoelectric equation, beta. H into your F will be equal to work function plus of your stopping potential E into V naught. And frequency is doubled, that is H into your 2F. That will be equal to your work function is W naught plus what will be the stopping potential? I don't know, V naught dash. Okay, so if I simplify both of them better, substituting the value of HF from the first equation. So it is 2 times of HF. HF value is how much for me here? This is 2 into your HF. I can write here is equals to work function plus E into V naught dash. In the place of HF, you write this one 2 times of your work function plus E into V naught is equals to work function plus E into V dash. So it is 2 times of work function plus 2 times of electron volt. That will be equal to your work function plus E into your V dash. Okay. So if I calculate V dash value will be equal to 2 times of V naught plus work function plus charge of electron. So obviously V naught dash will be greater than 2 times of V naught. So it is increasing. So it is more than double way. Okay. Next one is heat chapter. Question number 29. Anyone better? You can do it out. Question number 29. The equivalent distance between the points P and Q if value of each resistor R is NR divided by 6. The value of your N value will be equal to how much? All of them are equal better. You just need to identify which are series and which are parallel. Now see, I'll get here equivalent resistance. Say for example, each of them are having a value of your R. This one is R. This one is R. These two are in what? Parallel. These two are what in parallel. This is Wheatstone bridge. In the Wheatstone bridge, P by Q is equals to R by S. This will be ineffective. That means between P, we are having one resistance. This will be equal to R by 2. This to R and R will be in series. That is, this equals to 2R. This one will be 2R. 2R and 2R will be in parallel. So 2R by 2. So it will be equal to how much for me? R. So this is middle one resistance will become for me R. Then last resistance, all of them are parallel. So it is R by 3, same. This is Q. This is your P. So now all of them are in series. So R equivalent will be equal to how much for me? R by 2 plus R by 3. So if I take the LCM will come out for me 6. This here it will be equal to 3R plus here it is your 6R plus here it will be equal to 2R. So 6 plus 4, 11. It is 11R divided by 6. So given value is NR divided by 6. So value of N will be equal to how much for me? 11. Got it? Sure. Question number 30, again, very good question. Can anyone try it? In the network shown below, the value of V naught and ID will be equal to how much? That means current through the diode. Anyone? In the network shown below, the value of V naught and diode current. Done, beta?
Sir, option
Option?
2.
See, this is positive means this is connected to positive terminal, this is connected negative terminal. That means there is a flow of current like this. So silicon will be equal to on forward biased. Isn't it? Then if I take the germanium, this is the negative terminal beta, isn't it? And this will be your positive terminal, isn't it? If there is a flow of a current right now in this one, that means this will be equal to your positive, this will be equal to negative. This one is negative and this one is positive. Clear?
Yes.
That means when it is been connected, P is connected to germanium. This is output potential and it is connected to negative terminal of a battery. So germanium is in the forward bias or reverse bias?
Reverse.
It will be in reverse bias. It will not allow the flow of current. So when there is no flow of a current in that one, so output potential will be zero. So current flow is also equal to zero. So best option is right now for me C. Done?
Yes.
Sure. Question number 31. For an electric bulb connected in series with a variable capacitor and AC source, its brightness increases with increase in capacitance. Reason: capacitive reactance decreases with increase is in capacitance of capacitor. In the light of above statement, choose the correct. What is telling? In electric bulb, this is your electric bulb and it has been connected in series with a variable capacitor. There is a variable capacitor and it is connected to an alternating source of your U. This is your C and this is your bulb. That means it is connected to resistor, isn't it? So when it is connected to the resistor, current flow from this one will be I is equals to E divided by under root of your R square plus of your XC square, isn't it? So whenever electric bulb is connected in the series better with a variable capacitor, its brightness will obviously will increase because when XC is increasing, current is decreasing, isn't it? Hence the brightness of the bulb will increase. Brightness of the bulb means power P is equals to V square divided by R. If resistance is decreasing, the current will be your increasing. So the brightness of the bulb will increase as the current is increasing from the decrease of capacitor. So both A and true are correct beta and R is a correct explanation for your A. Capacitor reactance decrease in the XC value, isn't it? With increase in the capacitance of capacitor. That means storing has been increasing. So obviously the flow of the current in this one is also increases. So as the brightness of the bulb increases, as the current is increasing with the decrease of the capacitive reactance. So the best option is that both of them are correct and second reason is a correct explanation for your assertion. 32. Now you need to do this one better. In YDSC, monochromatic light falls on a screen 1.80 meter from two slits separated by 2.08 mm. The first and second order bright fringes are separated by 0.553 mm. The wavelength of the light will be used equal to how much? For the first bright, what is the formula beta? Y1 is equals to your lambda into capital D divided by small d. For second one, it is Y2. Y2 is equals to 2 into lambda into capital D divided by small d. Difference of this one is given for me problem. Y1 minus Y2 is equal to how much? 2 lambda into D divided by D minus lambda into capital D divided by small d. That means it is lambda into capital D divided by small d. So wavelength will be equal to how much for me? Lambda is equals to Y2 minus Y1 into your small d divided by capital D. Now substitute the values, but Y2 minus Y1 is given in the problem how much? 0.553 mm, isn't it? And small d is given for me how much better? Small d is given for me 2.80 mm. And monochromatic falls on a screen. That means capital D is equals to 1.80. All of the values are given. Just substitute to get the answer for this. I'm leaving that one for you. Just take care of that one. Today evening also there will be a class beta from 6 to 5. Sorry, 6 to 7.
Okay, sir.
Question number 38 with anyone? Question number 38. Identify the correct output signal Y in the given combination of the gate for the given inputs of A and B. If it is A, here it is your A bar. If here it is B, it will be your B bar. So Y value will be equal to how much better? It is your A bar double bar, not now. So that means it will be equal to your A double bar. It will be plus B double bar. So why A double bar is right now A? It is your A plus B. Okay. So A plus B means what will be the output beta? Can anyone tell me? Truth table you write for your A plus B. This is A, this is B, this is 1. Tell me. 0, 0. Y will be 0. Okay. In this one, if it is A 0, it should be 0. Y should be your 0. Okay. Then 0, 1, 1, 0, 1, 1. 1, 1 will be equal to 1. Output. Last should be equal to your 1. 0 to 5, 0. With respect to diagram, if I'm giving this 0, this is 1. Input will be equal to a straight line. It should be a straight line like this. Then if I'm taking this one as 1, isn't it? And this one will be equal to your 1. This one is 0. This is 1. So obviously this is 1. This is 1. So output should also be equal to your 1. Okay. Pi to middle work. దాని తర్వాత it is 0. This one is 0. This one is also 0. So output should also be equal to 0. Should be 0 here right now for this one. Between this one, it is 0. So D must be the best option for the given diagram. Got it? Question number 41, beta anyone? The RMS current in an AC circuit is 4 ampere. If the wattless current be 2 amperes, what is the power factor? What is the power factor formula? Cos phi is equals to your R divided by Z. What is wattless current bit? Wattless current will be equal to your IRMS into your sine of your phi. Wattless current is how much for me here? 2. RMS current is how much for me? 4 into sine phi. So from this one, I'll be getting sine phi value is equals to 1 by 2. So that means phi value is equal to how much for me? 30 degrees. So cos 30 degrees will be equal to how much for me? Root 3 by 2. Clear? So power factor will be equal to R by Z. That value will be equal to root 3 by 2. Direct formula of this question. You can try once the question number 40 beta. Then you can try question number 37 1. Question number 36. You can try question number 34. Question number 33. Okay. So we meet again at 6 o'clock. Sure. Bye.
Thank you.